Hey Trans Math 2 class, these are the notes for section 2.11. Alright, so the first activity, somewhat reviewing here, it says write two common multiples for the two numbers. Now, since we have a 2 and a 3, 3 is not a multiple of 2, so the best thing is usually to multiply them together, and that would be your first number, which is 6. And then just start counting by 6's, so 6, 12, 18, and so on. We only have to write 2. Okay, same with 3 and 4. 4 is not a multiple of 3, so we can't start with 4. So let's multiply them together, and we get 12. And then we'll just count by 12, so we'll add another 12 and get 24. And same with these two, 4 and 5. We'll multiply them together and get 20. And then we just count by 20s, so 20 and then 40. And same with these, 5 and 6. Multiply them together and we get 30. And then we count by 30 and we add that and we get 60. Okay, so we're just going to go through some more adding fractions or subtracting them when denominators are possibly different, and just kind of maybe visualizing it a little bit. So if this was representing one whole and half of it was this light green one and a third of it would be like this red one. So if you think about it, when we add 1/2 and 1/3, we're going to get something that's still a little bit less than 1. So they kind of break this down. And the reason why we have to get common denominators is because, what we're going to find is that 2 and 3, if we multiply them, we get 6 for the common denominator. So if we were to break this into 6 equal pieces, if we cut it in half and then we did our thirds on that, and same thing here, thirds, then we can write some equivalent fractions, because 1/2 is the same as 3 of those 6. 1/3 is the same of 2 is the same as 2/6. So then when we add those together, we can see we get a total of 5/6, right? And if we were just doing this problem without all this, visual analysis of it, we would just say, okay, I need to change this by multiplying by 3 so that I can get a 6 there, and multiply by 2, and then I rewrite my fractions, because 3 times 1 is 3, 3 times 2 is 6, and on the other fraction, 2 times 1 is 2, and 3 times 2 is 6. Then I just add the numerators. 3 plus 2 is 5, so I get 5/6. Okay, they're just kind of giving us a visual demonstration of how that works. 1/2 is the same as 3/6, as they show here, right? 1/3 is the same as 2/6, and that's what we changed them to, and then when we add them together, we get 5/6. So think about the denominators first. If they're already the same, you don't have to do any work. You just have to add the numerators together. So 3/12 plus 7/12, 3 plus 7 is 10, so 10/12. Sometimes you can get by with just changing only one denominator. So, and that happens when the bigger denominator is a multiple of the smaller. And so on this one, we can multiply by 2 and change that to a 10, and then we would get 2 times 4 is 8, and 2 times 5 is 10, and so then we can add 8/10 and 7/10 and get our solution that way. I guess they didn't write the solution. So if we go, it was 8/10 plus 7/10, then we're going to get 15/10 for our answer. And then sometimes we do have to change both of the denominators. So, if we have 3 and 5, the common multiple is 15. So we go times 3. That's what they're showing here. Oops, sorry. Times 5 here. Times 5, and then times 3 times 3. Okay, and so that's how we're going to get 5/15, 5 times 1, and then 2 times 3 is 6. So now then we can add these together. 5/15 plus 6/15, which would equal our 11/15. Okay, so more practice here. Multiply 9 times what to get 18? Well, that would be 2, and so it looks like we started with 9/9, so we got to multiply by 2's top and bottom, so 18/18. You're just making equivalent fractions here. If we had 4/3 and we need to make it with a 12 on the bottom, it'd have to be times 4 and times 4. 4 times 4 is 16. 1/5, and we want to change it so we got a 20 on the bottom, so times 4 1 times 4 is 4. And the next one, we want to have a 24 on the bottom, so we have to take 8 times 3. So we have to do top and bottom times 3, so 3 times 3 is 9. And on the last one, we want a 20 on the bottom, so 10 times what is 20? 10 times 2, so we're going to put 2's there, and 3 times 2 is 6. Okay, so here we're just left to do the problem. So common denominators already. 4 minus 1 is going to be 3. So we get 3/6 for that one. Okay, for this one, 3 and a 4. So common multiple there would be a 12. So we're going to multiply by 3. And we're going to multiply by 4. We're going to rewrite those fractions. So this would be 8 over 12 for the first one. And the next one, this would be 3 over 12. And 8 minus 3 is 5. Our answer would be 5/12. Alright. Part C, this one looks like we only have to change one fraction, because I can change that 2 into an 8 if I multiply it by 4. So times 4 times 4. And we rewrite this, 20 over 8. So it's 20 over 8 plus 4 over 8, which is 24 over 8. Part D, we have a 3 and a 5. It looks like we'll have to change them both. And our least common multiple will be 15, so I'll go times 5, times 5, times 3, times 3, and let's rewrite those. This would be 5 over 15. And next up, we would have, this would be 3 over 15. And so 5 plus 3 would be 8. 8 over 15. Okay, next one. Looks like we can just change the one denominator. We can change a 3 into a 9 if we multiply it by 3. So times 3 times 3. So that gives us 3 over 9 plus 1 over 9. And we get 4 over 9. Okay. All right, it says answer the questions about the parts in the rectangle for each grid. Remember to do the following. Find the area of the entire rectangle, find the area of each shape inside the rectangle, and then answer the question. Okay, so what fraction of the entire rectangle is made up of shape A and shape B? Okay, well, let's figure out the whole rectangle. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So it's 6 by 4. The total number of squares, if we count them all, there'd be 24 squares. So that means my bottom number is 24. Now, here, what fraction of the entire rectangle is made up of A and B? Well, let's count how many shaded, well, if we count the squares in A and B. Well, I can see that A and B is everything except for the 4 down here, so that's going to be 20 if we count those. So 20 out of 24 would be what I'd have if I counted up all of the squares in A and B. Total is 24. How much greater is the fraction that is made up of shape B than is the fraction that makes up shape C? Let's count this out. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 out of 24. That's my shape B. C is only 4 out of 24. And because it says how much greater, that means I want to subtract those. So 12 minus 4 is 8. So B is 8/24 bigger than C. All right. Someone says the fraction that is made up of shape A and shape C is the same as the fraction that is made up of shape B. Is this statement correct? Okay. Well, let's count it out. So 1, 2, 3, 4, 5, 6, 7, 8. A is 8 out of 24. And we know C is 4 out of 24. So if we add those, we get 12 out of 24, which is the same as what we said B was when we counted that. So the answer to that is yes. Is this statement correct? Yes, it's correct. When I add A and C together right here, A and C, I get 12/24. That's the same thing that we had for B right here. So yes. What fraction of the entire rectangle is made up of D and E? Okay, well, let's see. What is the rectangle? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So 8 times 5 would be 40. So our bottom is going to be a 40. And then we need to count up both D and E. Well, if I count up f and subtract that from 40, 2, 4, 6, 8, 10. So there's 10 there in f, so that means the rest of it has to be 30. So if I add up d and e, I'm going to get 30 out of 40. How much greater is the fraction that is made up of shape e than the fraction that is made up of shape f? Okay, so we're going to subtract two fractions. They're both going to have 40s on the bottom. So e has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We got 15 there. And f has 10. So when I subtract those two, that would be 5 out of 40. Number 6, what fraction of the entire rectangle is made up of D, E, and F? Well, that's easy. That's all 40, right? 40 out of 40, because that's everything. Circle the answer above that is an improper fraction. Well, this one's the improper fraction, because it's same number on the top and bottom. Okay, so those are your notes for 2.11.